Leah, for those who don't know, is with a background in machine learning, deep learning, and applied statistics. She's also a data scientist at Fiddler, which is an explainable monitoring company that helps address problems regarding bias, fairness, and transparency in AI. Prior to Fiddler, she spent time at various companies like Zillow, AXA Rosenberg Investment Management, and Airbus, focusing on machine learning and deep learning to solve business challenges. Leah received her master's degree in data science from the University of San Francisco and master's degree in statistics and econometrics from Toulouse School of Economics. So with that being said, I'm going to turn my camera off, and Leah, I'll let you get to it. Thank you so much for joining.
Thank you so much, Dave. Let me share my presentation. Awesome. Well, so hi, everyone. Thanks for joining me today. And a special thanks for the MLOps Micro Summit to give me this opportunity. Really appreciate it. So as Dave said, so my name is Leah. I'm a data scientist at Fiddler. So Fiddler is an explainable AI platform designed for the enterprise. So we provide a unique solution that enables developers to monitor, analyze, and explain their AI model. We also enable business teams to understand AI solutions and build trust with AI systems. So business and compliance teams benefit from our human-readable explanations while ensuring regulatory compliance with monitoring. So as you might know, training and deploying machine learning models is relatively fast and cheap, but maintaining, monitoring, and governing them over time is usually difficult and expensive. So today I'm going to talk about explainable monitoring for a successful impact with AI deployment. So, you know, models have many interactions within a business, multiple stakeholders, and varying requirements. So usually businesses need a 360-degree view of all models within a unified modeling universe that allow them to understand how models affect one another and all aspects of business function across the organization. So we all know that most models are black box, right? But so that means we don't have visibility into model performance, no monitoring to catch potential bias or drift, and we don't have explanation of the model behavior. So all of those problems raise some questions for people interacting with the AI product. So for example, the business user would ask themselves if they can trust the AI, right? The customer support would like to know how they can answer a complaint, for example. For IT and operations, the challenge is to know how to monitor and debug the machine learning model. As data scientists, we want to know how the model works. And finally, you know, auditors and regulators would be interested in knowing if those decisions are fair or not. So what you should ask yourself: are you confident about your AI performance? And do you have the necessary visibility into it? So is your AI ethical? Is it transparent? Is it compliant? So, you know, being able to answer all those questions is very important because black box AI can cause serious risk. And we can see that in the recent news stories about bias in credit lending, hiring, and healthcare AI algorithms. All of that demonstrate what can go wrong when there is a lack of transparency and visibility into AI solutions. So a breach of ethics can lead to negative press release. So I don't know if you heard about the Amazon recruiting tool that was biased against women. So basically the company experimental hiring tool used AI to give job candidates scores ranging from 1 to 5 stars. And the idea was, I'm going to give you 100 resumes and it will spit out top 5. But in 2015, the company realized that its new system was not rating candidates for software developers jobs and other technical posts in a gender neutral way. So, and that's because, you know, Amazon computer models were trained to vet applicants by observing patterns in resumes submitted to the company over the 10-year period. And most came from men, which, is a reflection of male dominance across the tech industry. So the Amazon system thought itself that male candidates were preferable, and it penalized resumes that included the word women's, for example, women's chess club captain or things like that. So you have other stories like the Apple Card that had some gender discrimination, etc. Moreover, the lack of transparency causes a mistrust and operational inefficiency. So entities could get fines and regulatory actions if their machine learning models are not compliant. For example, you have JP Morgan Chase agreed to settle a federal lawsuit that accused the bank of working with mortgage brokers who discriminated against minority borrowers for years by charging them like $1,000 more than white customers. So, explainability enabled this observability by unlocking black box AI to provide visibility, insight, and trust of your models. So explainable AI unlocks the AI black box to combine the power of AI and human judgment for trusted decision making. So what is explainable AI? In most organizations, there is no feedback loop after a model is deployed. And so if a model is making poor decision, then the situation gets worse. And there's also some confusion about the AI decisions. So it's hard to understand why the AI forecasts those results, for example. So a better approach is to track data that is being fed into the training process, the features that are generated as well, the predictions that are coming out, and the labels. And then you create a feedback loop into the model training process. So like this, you can create better models over time. And that way we are able to explain performance problems. So that's why we need explainable machine learning, right? We want clear and transparent decisions so we can understand the success and the failure, and we can also trust the insights. So explainable AI, it's an actionable way to manage machine learning models since it enables team to deduce the internal states from the external outputs, right? So it's very critical to understand the why behind issues to quick resolutions. So what's the current user workflow in explainable AI? So it's composed in 5 steps. So the first one is to ingest. So you import your machine learning models, you monitor your data. Then the second step is to monitor. You visualize the predictions. You also visualize the data drift, the outliers. You want to ensure fairness and performance in your machine learning model. Then you want to set some alerts on configurable thresholds. And if a problem arises, you're going to debug. So you want to investigate and analyze spurious model behavior. And from there, you can get actionable insights to drive improvements. So what is the state of monitoring today? Today, there are 2 approaches to monitor production software. The first one is business metrics monitoring via telemetry. So it's used by business owners to track business health. And then the second one is service or infrastructure monitoring. So this one is used by DevOps to get a broad operational visibility and service health. Neither of those approaches provide a critical machine learning model level insight that a data scientist or a machine learning developer needs to operationalize a deployed model. So monitoring machine learning models become very important because unlike traditional applications, model performance is non-deterministic, and so it depends on various factors such as seasonality or new user behavior trends or data pipeline and reliability leading to broken features, etc. For example, you could have a perfectly functioning ads model that might need to be updated when a new holiday season arrives. Another example, a model trained to show content recommendation in the US may not do very well for users signing up internationally. So things like that. And finally, there's also a need for alerts and notification to detect model degradation quickly and to take actions. So let's take a look at the unique challenges of AI monitoring. So first, performance of machine learning models can degrade after release, and bias can surface after the release as well. So we want to monitor after release in production, right? There is also a high risk of data quality issues in automated machine learning pipelines. Then you can have performance issues that go undetected without real-time ground truth levels. And usually performance measurements need other leading indicators such as prediction drift. And finally, as we know, machine learning models can be black box, which lead to root-causing problems, right? So what is the monitoring solution for AI? So after deployment, machine learning models have these 5 unique challenges, operational challenges. So the first one is shifting trends in the input data, so what we call data drift. Then you have bugs or issues in upstream systems, so that's we call data integrity. Then you can have model performance problems. Then you have like outliers that warrants investigation. And then you have bias risk. So let's detail those one by one. So first we have data drift. Drift is a change in an entity with respect to a baseline. So data drift is defined as a change in the distribution of data. So in the case of production machine learning models, this is a change between the real-time production data and your baseline data sets, most likely your training set. And your training set is representative of the task the model is intended to perform, right? Machine learning models, are trained on finite data sets, and so they can encounter novel cases in the wild, right? If overall data trends diverge from those of the training set, so then your model performance can suffer. So monitoring data distribution changes provide a warning sign of this risk, and we could decide, for example, to retrain the model or things like that. There exist different types of data drift. So the first one is label drift. So this one is a shift in the output distribution. So this does not necessarily affect the model's accuracy, but it can affect the business. For example, if the ratio of people eligible for loans suddenly increases or decreases, it may lead to a loss of opportunity in business for a lending company, right? Another example, if you have like a larger proportion of creditworthy application that start showing up, and this may be because you launch, your product in a more affluent area, for example. So your model still holds, but your business may be unprepared for this scenario. So then there is feature drift. So this time it's a shift in the input data distribution. But in this scenario, the model is still valid. So again, like label drift, this may not affect a model's accuracy by itself. And some drift in data is actually to be expected, but that could lead to issues elsewhere in the business as well. So if the model starts seeing data that it has not seen during training, you could have some surprises, right? And then finally, we have concept drift. So this time it's a shift in the actual relationship between the inputs and the output. This is the hardest type of drift to catch and prove, especially if there is a lag in receiving ground truth level for production events. And we kind of know, for production, usually we have a lag. And so in this case, the model is no longer valid. So to give an example of concept drift, you have macroeconomic factors that make lending riskier, And so there is a higher standard to be eligible for a loan. So in other words, an income level that was earlier considered creditworthy could be no longer considered creditworthy, right? Okay, so now let's talk about data integrity. So there are different types of data integrity issues. It can come from missing values, a range or type mismatch, or even a schema mismatch. So those issues can cause some problems because they slowly degrade model performance over time. And in extreme cases, they can tank your model performance. How do they arise? So, business data is dynamic, and so its composition is constantly changing. For example, you can have a newly cataloged product or a revoked pricing. So all of those could cause a schema change, right? And moreover, the pipelines, the data pipelines providing that data to a model are usually like complex and fragile. And so you can have breaks, bugs, or other issues in upstream data system that can pose a risk to the models. Then we have model performance. So, unlike other software, the machine learning model performance can decay over time. So monitoring for correct model outcomes when it's available provide immediate business impact change notification. So being able to monitor model decay will help us to know if it is a time to refresh the model, for example. Data drift, data integrity issues, and outliers can all contribute to gradually decline the model performance. And so selecting the right performance metric is important to ensure that your model is performing optimally for the task at hand. So the model performance metrics commonly used. So for a regression model, you have mean squared error, mean absolute error, S-square. For binary classification models, you have log loss, accuracy, F1 precision recall. And for multi-class classification, you have accuracy, log loss, average F1, etc. And model performance is usually the best indicator for concept drift, but this requires having labels. And as I said, it's not always the case. And finally, prediction drift is a good proxy metric for model performance usually. Then, we have outliers, and outliers are very important to identify. Deployed machine learning models can run into data that is far outside the training distribution. And this outlier can cause some isolated performance issues that are difficult to debug globally, usually. So being able to pinpoint them in real time can provide insight into addressing those issues right away. For example, on a hiring platform, applicants with a rare degree, so for example, non-commonly awarded in the US, could be getting a very high score just due to very few highly rated instances in the training data. So you may know that, but detecting outliers is a challenging problem as there are a variety of techniques that can be applied, and it has been very well studied over many years, right? And it becomes even more challenging in the context of machine learning model performance because we need to study outliers as a multivariate analysis problem across, a large number of variables, and also see its impact on the model behavior. So we'll determine if it causes the model to act erratically, for example. You have different typical approaches to identify outliers. Like you could have domain-specific rules. For example, let's say, I don't know, income greater than 2 million and age lower than 20 years old, then you flag an outlier. You could have statistical methods such as Mahalanobis distance and PCA. Then you have supervised machine learning classification models and supervised machine learning models as well. Those are not constrained by the lack of label data, and so they are more resilient to the newer types of outliers as compared to supervised methods. And finally, bias risk. So model bias is an important and growing problem in machine learning. you have ethical and legal reason to address bias. And as I mentioned earlier, a breach of ethics can lead to a negative press release, or even worse, like regulatory actions, right? The thing is, like, bias definitions might change from organization to organization, country to country, depending on the laws in place, and also from problems to problems, because there is no unified definition of fairness. So we should be able to support a pluggable policy to and enforce it continuously to detect any potential bias issues. And if you detect some bias, it's important to drill down into the causes to determine if the model needs to be replaced, or if it's just a data pipeline issue, things like that. I think the first defense could be to drop what we call the protected attributes. So protected attributes are, race, gender, age, things like that. You can find a list of those protected attributes. So I think the first defense could be to drop those during the training process. But, models could also exhibit bias due to other features that are very correlated with the protected attributes. So what we need instead is a continuous tracking of the models around fairness, where these metrics are computed on the fly and in real time. And usually, explainability help assess for bias, right? So why bias monitoring matters? Even after monitoring for data changes, its true impact on protected groups might change despite the model validation. So that means a model could become biased after deployment. For example, a machine learning model recommending job candidates could have a meaningful different sensitivity or recall in male vs female applicants between your training and your production system. So monitoring for bias can catch this issue when a system starts to deviate towards unfair output, right? And then the second thing is, like, it can be because due to some data issue, either due to drift or due to data integrity issues. So even because of that, an unbiased model could exhibit bias after deployment. So for example, let's say, female customers are more likely to be acquired from a website A and male customer from a website B. If you have a simple data collection issues at the website A, where the location field is optional, for example, that could lead to the model giving lower scores for women. So to wrap up, a robust AI monitoring system requires integration with model serving infrastructure to guard against those 5 operational challenges. So model performance, shifting trends in the input data, so what we call data drift, the outliers that weren't investigation, the bugs or issues in upstream systems, what we call data integrity, and the bias risk. And so by monitoring and tracking those 5 points, you get the feedback needed for managing your deployed machine learning system. So it allows the users to easily review real-time monitored output for spotting KPI or other issues, or act on alerts. So investigating operational machine learning issues that are flagged often takes a lot of effort. So the black box nature of machine learning models makes them especially difficult to understand and debug for machine learning developers. So with observability, the user can understand the problem drivers, the root cause issues, and analyze the model to prevent a repeat, for example. So by setting up alerts, you have a faster ability to, root cause, solve problems quicker, and maintain high performance models. So that's why the need of setting up alerts. And you know everything about explainable AI. So thank you very much for your attention. And I hope you're aware about explainable monitoring now, and you will start using it, for a successful deployment of your machine learning models. So if you have any questions, feel free to write those. I think we have like 5 or a little bit more minutes to do that, and I will try to answer. Thank you. Okay, so I see your first question. Which type of data drift do you see most frequently? So I think, as I said, it's mostly feature drift. I think the concept drift is there, but it's usually really hard to detect. Usually, if you need to replace your model, that means like you have a concept drift, right? But if your model still holds, then you most likely have feature drift. And I think those two are really hard, to maybe get the difference. But yeah, I think like the feature drift is like the one you see most frequently. Let me see. Can you give an example of concept drift with respect to data drift? And are there any structure to measure or flag it? Yeah, that's a good one. I think as I said, let me come back to the drift. Yeah, so I think I think the concept drift is the most tricky one. And I think kind of like the picture is a way of, kind of like a way of trying to show that. So I think the difference between the feature drift, so the data drift, and the concept drift is really that with concept drift, your model don't hold anymore. So you can see on this picture, you have your original model, and then what is called virtual drift, it's a feature drift. So you can see your data change, but still your model is is holding. But then for concept drift, you need to like update your model. And those as I think I gave like this example for concept drift about your microeconomic factor that can make lending riskier. And so so usually it's because of those kind of like kind of factors that can have impact on your models and on the decisions that you need to refresh your model. Any tip on how to convince product manager on the importance of doing this? I think that's a good question. Honestly, I think a couple things. Definitely for me, the risk of bias and fairness is very important. So I think it depends. Maybe it could be very important depending on which sector you're working on, right? But for some parts, that's something we should definitely address. Well, definitely because we have some it's ethical, and we wanna be ethical, right? But I think some people will be more motivated. It's because you can get some fines. So I think because of both of that, we should definitely like that's something we should check and make sure your model are not biased toward some predicted attributes. I think for the other part, what you could show to your project manager could be this slide. Let me check. I think one of my first slide with the nice, yes, this one. I think that's a good way of like understanding your model. Everyone would be happy, right? Because your product manager will be convinced that you are delivering, a model that is working as expected and is delivering the good, and the why behind like why it's giving those results could be like interesting. So I don't know. Yeah. I don't know if you guys have any more questions. Well, thank you. Thank you for your questions. And thank you for the MLOps Microsomic team. That was great. Really happy I was here tonight to share with you. Yeah, I think if there's no more question, I think we can go. But thank you very much, everyone, and have a good evening.
Yeah, I just wanted to say thank you so much for a great talk.
Yeah, thank you so much. That was
Awesome.
thanks for the opportunity. Yeah.
No worries at all. I'll see you soon. Take care.
Thanks. Bye.
Bye.